I want to spend a little bit of time talking about average atomic mass. So, we talked about atomic properties for individual atoms, defining isotopes, and all these ideas. And so we know now that for a particular element, you have different isotopes that all have that element, like carbon. Right? You have carbon 12, carbon 13, and carbon 14. And for reasons beyond our class, but there are only certain isotopes that exist, and certain of them are more common than others. So while you could theoretically imagine you have carbon 85, where 6 carbon, 6 protons, and then 79 neutrons, that doesn't exist in nature. Those nuclei just don't exist. They're not stable. And so carbon is instead almost all carbon 12. 99% of carbon atoms are carbon 12, about 1% carbon 13, and less than 1 10,000th is carbon 14. And so if you have a sample of carbon, for example, graphite, this image here on the right that we have, there's a bunch of carbon atoms in there. And they're not all going to be the same. They're going to follow these ratios. So if you were to zoom in, you would have mostly carbon 12s, about 1% carbon 13. And you can see in this little snapshot, there's not even any carbon 14. They're very, very rare. Now, atoms are really small. So in a piece of graphite, you have literally trillions and trillions of atoms. So there are some carbon 14s, just relatively not that many. The important thing is their chemical properties are all the same. We call it graphite, we call it carbon, and they all still behave as carbon. So the things that are different between the atoms are then primarily physical properties. And the physical properties of that sample of carbon are going to be a weighted average of all the different isotopes that we have. So the most important property is average atomic mass. So the average atomic mass is a weighted average of based on isotopic abundance. So you have carbon 12, 13, 14. Their masses are about 12, 13, 14. I should note this is atomic mass. That is different than mass number. These are in actual AMUs. So one of the things you can see is they're not perfect integers. There's these 3s out here in these digits. There's potentially non-zero digits back here. These are not exact numbers. These are rounded numbers. Lots of sig figs, but they're rounded. And so we have those atomic masses in AMU. We have percent abundances that we can figure out experimentally, and we can use that to determine what the atomic mass is. So an average carbon atom has a mass of 12.01 AMU. Carbon 12 is close to 12 AMUs, and carbon 13 is close to 13 AMUs, but on average, we're in between that. And there's so little carbon 14 that it really doesn't actually matter what it is. It doesn't affect the average mass because they're so uncommon. And so we have this 12.01 AMU. That really does, kind of represent the average. And then you can tell it's really close to 12, which is significant, or represents the fact that 99% of carbon atoms are carbon 12. So the average mass is going to be pretty close to 12. It's just important to know that these, when we talk about mass, there are some different representations. These average atomic masses we'll see are on the periodic table, kind of a representative number of that element, but they are representing an average atom. There is no carbon atom, with this actual mass, right? They are either 12 or 13. This 12.01 is an average representative of that average. And so one of the most kind of practical uses of these is they inform what the most abundant isotope is of an atom. So for example, if we look at, say, magnesium, Mg, we can see that average mass is 24.3. Well, magnesium has 3 stable isotopes, but an average magnesium atom has a mass of 24.3, which is close to 24, which tells us that magnesium 24 is the most common of those isotopes. We can see it's not maybe as dominant. It's not as high of a percentage. If we look over here in the top right, we can see it's like 12.01, 14.01, almost perfectly 16, almost perfectly 19. That's because those elements really only have one dominant isotope. And you could predict for carbon it's 12. For nitrogen it's 14. For oxygen, it's 16, and for fluorine, it's 19, right? They are basically only one isotope, so the type of isotope that exists, so the average atom is just that isotope. Whereas something like germanium, 72.6, 73 is probably the most common, but there's a much bigger mix there, a lot of different types of isotopes. You can see a lot of elements are really close to just one number. Gold 197 is really all that there is, but sometimes there is a mix of the isotopes that are present for that particular atom.